Welcome to my mad laboratory where I create all kinds of evil equations and crazy mathematics. Today, of course, we will be designing another intimidating arrangement of numbers and terms. But first, let me introduce you to my new assistant. After all, every crazy mathematician should have one. Her name is Zeta. She's there to help me out with this video. Alright, so let's begin. Zeta, if you could bring us our first specimen. Ah yes, this thing. I featured this simple expression before in some of my other videos. It's one of my favorite ways of creating the number 2. X plus x is 2x. And then we just cancel out the x's. What makes this type of equation interesting is that x, with the exception of 0, can be just about anything. We could, for example, take this famous indefinite integral, and we can replace the x's with it. Look how neat that looks. Keep in mind that there's no actual solution to this thing that can be expressed in comprehensive math terms. Now, I also like to make these equal to 1, like so, just so they can fit with other crazy monsters later on. But let's get back to our original equation. Maybe I will make some video about this integral one day. But today I want to deal with some complex numbers. The reason I want to use complex numbers, aside the fact that it's one of my favorite maths, is because complex numbers can be expressed in 3 unique ways. We have the basic triangular form, which is of course the original way to write these numbers. Then you have the polar form, which takes some figuring out using trigonometry, but isn't too hard to arrive at. And then you have Euler's form, which, well, takes a little bit of math to get to, and is usually derived from the polar form using Taylor sums. It lets us use this nice, manageable version where the angle is just a power of e. I made a video about this a little while ago. It gets quite heavy on the math, but I do recommend checking it out if you are into complex numbers. With that said, let's get to designing our evil equation. So let's make our complex number. For this one, I decided to use pi for the real part, just because pi is awesome. And let's make the imaginary part into 2. So now let's convert this into polar form. Radius becomes this thing, and theta becomes this. And finally Euler's form, which is just this. Now that we have these 3, let's plug them into our original formula, like so. And our equation already looks like it's going to give some students nightmares. We can pull the 2 out to make the whole thing equal to 1. Now look, I can also dump that integral from before, like so. How fun is that? This is why I like to make my equations result in 1. With this simple technique, you can do a lot of crazy stuff with just basic algebra. Okay, let's get back to the original formation before I get too carried away. Notice all these inverse tans. They all look the same. Let's change some of them so the whole thing becomes less repetitive. This can be converted to this. Pretty cool, I think. What about this 2 over pi over here? In my previous video, I featured a product notation that results in something similar, except the pi is over the 2. All we need to do is flip this and get our desired result. So let's put this thing in there now. Much better. Our creation is looking a lot more impressive now, but I think the denominator is a little bit big. So let's move this thing up by adding a little -2 over here. And look, we can cancel this thing now, leaving us with only one of those. So here it is, a scary looking equation built from nothing more than a simple complex number. This definitely deserves a nice AI rendition. Just look at this thing. Trigonometry, product notation, bunch of pies. It's just begging to go on a blackboard before your math teacher shows up. I love it. But let's do something more with this thing. Notice this e over here. Let's try to isolate it. First, we have to flip that to the other side. Then we subtract this. Now we need to do something a little tricky. We need to move this power here, but we don't want a giant root symbol. Fortunately, all we need to do is change this to a minus, and we can keep it as a power. And there you go, a very long equation that results in e. Now, this is okay, I suppose, but it does look kind of lengthy. So I'm going to turn this into a magic circle. It has been a little while since I did something with magic on this channel. Alright Zeta, why don't you demonstrate to us how we can use this circle to channel the power of Euler's number? Oh my, that was some powerful stuff. Let me know in the comments if you guys like Zeta, or if you guys want to see more stuff about magic. And yeah, subscribe, check my other stuff. I hope to see all of you in the next one. Have yourself a great day.